Ratio in a number line. Number lines can help us express ratios. We need at least two number lines to represent each quantity involved in a ratio. The units are not the same, but they correspond to the quantities they represent when viewed vertically. This allows us to very easily find other equivalent ratios, not only the one expressed in the simplest terms. In addition, expressing ratios in a number line allows us to identify smaller groups of elements formed, based on their given relationship. Let's see an example to clarify this point. Example 1. The ratio between the number of workers in a factory and the t-shirts they can produce in one day is shown in the figure in the following on screen. Calculate the daily production of t-shirts in the factory if 150 workers are employed in it. Solution 1. The numbers written in the same position of units are helpful in determining the ratio R, which in this case represents the daily production of a single worker. We call this type of ratio the rate. We will discuss this type of ratio in the next tutorial. Thus, we have the following shown on screen. Therefore, following this rule, we can work out the daily production if 150 workers are hired in the factory. Thus, we have the following shown on screen. Hence, we have the following shown on screen. Ratios expressed in the form 1:R. Practical situations as the one described in the question above may be also reconsidered, in order to express them as ratios of type 1:R. In other words, we may want to calculate how much from the quantity, B, is needed for every, A. We silently did this in the previous example, where we didn't start calculating the ratio from the first quantity A, but from the quantity B instead. This is because it is not very suitable to calculate how many workers are needed to produce one t-shirt in a day, as the result of ratio will be a decimal. 5 out of 80 is equal to 1 out of 16 is equal to 0.0625 t-shirts worker. Hence, we inverted the fraction derived from the ratio, and instead of calculating the ratio R, we calculated its inverse, 1/R instead. This is purely for convenience. Example 2. Most modern bronze is made with 88% copper and 12% tin. This means that in 100 grams of bronze, for every 12-gram tin there are 88 grams of copper. How many grams of copper are needed for every kilogram of tin? Solution 2. The tin to copper ratio for 100 gram of bronze is shown in the following on screen. Since this value is not suitable because it is very small, we deal with the inverse ratio. Hence, the inverse ratio 1/R, which shows how much copper is needed for every kilogram of tin, is shown in the following on screen. This result means we need 7.333 kg of copper for every kilogram of tin to produce modern bronze. That is all for lesson 4.1.2. To continue this tutorial, please watch 4.1.3, finding the fraction of one quantity out of the total. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.